Hey everybody, Lars here. Tonight I'm going to do the review video, the second review video for the Unit 2 slides. And tonight's a pretty important one because of all the concepts when you're first beginning to learn how to program, loops is a big one. So some people had confusion earlier. Some people sent me emails. George put something in the forums. So I wanted to go over loops and show you some code as I type it in because I think it's good for you to see them being used, and hopefully there'll be less confusion, because when I do the examples in the slides, I'm basically just printing sequences of numbers, and I don't want you to think that's what loops are all about. Loops are about taking sequences, strings, lists. Next unit you'll see files, and finding a process that you want to do on each item in that sequence, and the loop allows you to do that. It will go to each item in that sequence and run your code for you on each item, and as you will see, it does so incredibly fast, and it's one of the most powerful things about using computer programming and using computers to get the work done. You're going to hear me say it a million more times. Computers are dumb. They only do what we tell them to do. But when we tell them what to do, and we do so properly, they do it incredibly fast, and it's where the value is when it comes to computer programming. Okay, first thing we're going to do is a simple loop, but I'm not going to jump right in to all that craziness with the range. The first thing I'm going to do is I'm going to create a list. And I'm just going to create a very simple list by twos. And I will print my list to make sure we're good. And let's see what we get over on the side. All right, we've printed my list now. We're in the interactive window. I just want to show you, if you want to reprint your list, you just type it out and you'll print it out. That's the way you can do debugging and check some of the things your program is doing. So I have a list. What if I want to do something for every item in that list? Let's say I wanted to take the numbers in that list and find out what the square of each number is. So I say 4. 4 begins my loop, begins my journey through the sequence. I say I for the individual variable. I don't think I stands for individual. I may stand for index. I may stand for iterate. No one's really sure. I believe it hails from mathematics. I know that. But classically, the variables we use when we iterate are I, and then if we need another J, and if we need another K. And yeah, you see that in matrices math and some other things like that. So in this case, for I say in, and then my list, colon. So for every item in the list, I'm going to stick it in the variable I, and we can use it. Now, what do I want to do for this list? I want to print, and then I'm going to print the value. Actually, what I'll do is this. I'll print the value first, and then I'll print its square. And then, when I'm done, I will drop out of that loop, and I'll just print something at the end to show you that that will only print once. So down here, I have my code. I don't want to do that. So I can show you, there's my list, because I printed it up here. Then 2, the square, 4, the square, 6, the square. For every item, I performed that command in the list until the list was done. 10, 100. And then when the list comes to the end, Python knows this, you drop out of the for loop, and there's one command left at the end called the end, and we print the end. So that is one of the most basic loops I could show you. I'm just iterating through a list, and every time through the list, I'm doing the one command. I can do another command. I'm just going to print loop after each one. I'm going to show you. It'd be nice if I ended it with a close paren. Now it puts a loop underneath it. But you see, it did it for every time through the loop. This block is now run for each of the 5 items in my particular list. So you're not limited to just one command. You could put an entire block there, and that block will be run for each item in the list. Now, I I'm going to put this code up on Sakai when I'm done, so don't worry about it. You'll have it. But right now I'm going to block that stuff up because we're going to go do other things. So now we're going to talk about the range function and how we use it. In other programming languages, when we create for loops, what we'll do is we'll say for, and then we'll create a series of conditions and variables and how they're going to increment and tell the loop exactly how many times to run. This is called a definite loop. And the way we do that in Python is because Python only iterates over lists. What we want to do then is just create a list of numbers. I know I want to run my program, say, 10 times, or I want to loop through 10 times. So I'll say for I in, and then I do the function range. And I know I want to do it 10 times. So I'm going to start at 0, and I'm going to put 10. Now, it's a little tricky. I'm going to do it first, and then we're going to go back and talk about it. And here I'm just going to print I. When I run it, I print 0 through 9. So that's 10 times. It did it 10 times. But remember, the default for that is 0. So that 0 is right there. And the default increment is 1. So I could actually run this and get the same result. See? 0 through 9. But if I don't put it there and I just put the 10, it will assume I wanted to start at 0. And it will assume I want to increment by 1. So when you see a range with just one number in it, you're going to go from 0 to the number before that. Remember, the second one is exclusive. It's the first thing you don't want. Now, if I wanted to, create a list from 1 to 10, because I was doing a list or something like that, I would tell it I want to start at 1. Then what's the first thing I don't want to see? First thing I don't want to see is 11. So I want to print from 1 to 10. And as you can see, there we go, 1 through 10. It's not easy to explain to people why we have to start counting at 0 in computer science, but you get used to it. And later you'll find out that it's actually useful and it makes a lot of sense. So we did that with the simple range. We can tell it where to start. We can tell it what's the first thing we don't want. And then, and I can illustrate by doing this, we can even tell it how much we want to increment by. If I want to start at 1, go to 100, and only print out the numbers by 3, I could do that. And you can see here I start at 1 and I increment by 3 all the way up the line to 97. Why 97? That's the first thing I don't want. So even though when I started at 1, I should see 100 because the 99 would get you there. I don't see it there. We stop at 97 because that's the first thing you don't want. One other thing about range, which is pretty cool. So you can go backwards. Now, you have to tell it you want to go backwards, and you still give it your start, and you still give it the end. So I want to start at 100, but I want to go backwards and then end at 1. 1, as you will see, and I'm going to do it, it starts at 100. I'm going to come up here and show you the 100. And then it goes all the way down to 2, because this is still the first thing. It's easier if I do it with 10. Let's just do it right here. Boom. 10, 9, starts with 10 and goes to 2, because that is still the first thing that we don't want. So if I wanted to do a classic countdown, I would put the 0 there. And then I would go 10, 9, 8, 7, all the way down to 1. So the range is pretty good. What it does is it generates a list, and I'll explain generation another time. Sometimes loops get big, and the lists that you want to iterate through will also get big. So in a way to save memory, Python has these functions like range that don't really create lists unless you want them to. What they do is they generate the next sequence in a list. So it's not kept in memory, and it saves memory for you. I'll show you how to take a generator and create a list with it later, but when those for loops are using range, they're just generating the next number in a sequence, because you really don't have to keep that list in memory. So it's a memory saving technique. You don't have to know all of that. I just want to, let you know if you're curious if, range is creating a list, and I could show you how to do it later. But that's, if you're reading the slides and you see that behind the curtain thing, I think that's where I talk about it. Range is a generator. So it's generating the next sequence. But we don't have to worry about that. So range can give you a list of numbers. It can give you a list of numbers that goes backwards. It can give you a list of numbers that increments by different limits. It's pretty powerful. So the last thing I want to show you about this is that we are not limited to hard coding either. We can say num equals 10 and just put num in there. So if we do it again, we get the same result. Now, you're saying, why do we have to do that? It's only one. But if we had a series of loops that all use that number, then we'd want to create a variable. So you just change the variable in one place, and it will affect all of the different loops and all of the different places where you want that number to be used. So sometimes it's good to use a variable when you do that. So that is the basics of loops. We can loop through a list and have it do what we want for every item in that list or sequence. And we can also use range if we know how many times we want to go through a particular loop sequence or iteration. So let me move this and let me move this now. And this is something I wanted to do because in the slides, all I'm really doing is printing out numbers and showing you how range works and showing you how it does it for the iteration. What I want to do now is actually solve a problem, and solve a problem with some of the things that we've been learning. So I thought I would do this. I will ask myself how many squares from 1 to 100 are greater than, let's say 6,000. Are they 6? Yes, they'll be 6,000. So let's say I want to use the programming techniques that we've learned thus far to solve that problem. What's the first thing I want to do? Now, the first thing I want to do is produce the squares. You know, I need the squares if I'm going to look at them and see if they're greater than 6,000. So let's say for I in range, I'm going to start at 1 because I don't want to square 0. And I'm going to go to 101 because I want 100. 101 is the first thing I don't want. And what am I going to do? I'm going to print I, because that's the variable every time you go through, squared. All right, what happens when I do this? Okay, it prints out the squares for me. Pretty cool. All right, start with 1, 4, 9, 16, 25, 36. Okay. You see how fast that ran. And it went all the way up to 10,000, which is 100 by 100. So that's pretty neat, but I don't know that it's getting me to my answer. How many squares from 1 to 100? So what do I want to do? I could just test in here, but I think what I want to do is I want to create a list, and I want to keep those numbers in a list. So how can I do that? I'm going to create a blank list. And the way I do that is I say squares, the variable that's going to hold my list, equal to bracket, bracket, open and close bracket. And that will create a blank list. So then, as I iterate from 1 to 100, I'll take that number and I'll add it to my list. And I do that with the append method. So you can see I have my list name, then dot, and I run the special method that we can use with lists called append. Talked about it in the slides, but I didn't mention it in the last video. I promised that I'd do it now. And what am I going to add to that list? I'm going to add I squared. And then, after I've done my 100 iterations, I should have a list of all the squares. And I'm going to confirm that by printing it out. And there we go. So I created a blank list. I iterated 100 times and used that variable I every time through the loop, 1, 2, 3, 4, 5, 6, all the way to 100. And I squared the number every time, and I appended it to my list. So, pretty cool. That works. Instead of just printing it out, I now have it in a list that I can use. But it still hasn't got me to my answer. How many squares from 1 to 100 are greater than 6,000? Let's iterate through it and look. So now, instead of a loop with range where I know I'm doing it 100 times, now I'm going to iterate through the list. So for every item in the list, I'm going to perform an action. So let me say for I, it's okay to use I again, this loop is over. In squares, what do I want to do? I want to test it. If I is greater than 6,000, okay, now this is a new issue. How many squares from 1 to 100 are greater than 6,000? So let's say one of the squares, and you can see, I can see a bunch of them down here, so they're going to hit there. 1 is greater than 600. What do I want to do? I want to know how many, so I have to count them. But how do I count them? I guess every time I go through the loop, I want to have a variable that I increase by 1. That way, if it's greater than 6,000, it'll increase that variable and tell me, like, yeah, this was greater than 6,000, and then go get the next one. So how would I do that? I would do that by using a variable called a counter. What I'm going to do is above the loop, before we go into it, I'm going to create a variable called count. And then if I is greater than 6,000, I'm going to make count equal to, now count plus 1 is what? Exactly that. Count plus 1. So I'm going to start at 0, and I'm going to loop through all of the items in this list. And if that item is greater than 6,000, I'm going to add 1 to this variable. So after I've looped through the entire list, that variable should contain the number of times the variable was greater than 6,000. Let's see if the programming gods are with us. Print the squares greater than 6,000. Count. Yay! There's 23 of them. Do I need to count them? 1, 2, 3, 4, 5, 6, 7, 23. That is actually correct. All right. I'm going to do that. Read your slides. Get the point. Read the slides. And that separates that out. So there are 23. So we actually just did something semi-useful. We used a loop to create a list of certain kinds of numbers that we wanted. And then we used the loop to examine every item in that list to see if it met some condition, here greater than 6,000. And we used a counter to accumulate them and accumulate. I just foreshadowed. That was Freudian. To count how many there were. But going into what I was going to say, what if I wanted to also print out the sum of all of the squares that were greater than 6,000? Then I would use a variable we call an accumulator. And what we're going to do is if it's greater than 6,000, we're going to make the accumulator equal to accum plus, what do we add? We don't add 1 because our counter is doing that. We want to add the sum. So what do we want to get the sum at the end of the day. So what do we add when we're in that loop? We add the number itself, I, so that the number will be added to the accumulator all the way through. These are two pretty important concepts when you're dealing with loops in computer science. You can have a counter, which will count how many times that condition was met. And you can also, in the case where you're dealing with numbers and you want sums, is you can have what's called an accumulator. And I usually call it accum. So squares greater than 6,000, the count, and then I will say the sum is, and I will print accum. And I don't need that second paren, do I? No. And there we go. And hoping it's right, but I'm not going to test it. So those are two that's a way we could solve a problem, and we introduce counters and accumulators. So those are two things that you can do inside of loops. It's not just a matter of printing out numbers and printing out the list or doing things like that. You can do useful things. And counters and accumulators are two of the classic things that we do with loops. One thing I want to show you before I move on to while loops is nested loops. You can run loops inside of loops very quickly. For I in range, let's say 3, I'm going to print outer, and then inside the loop I'm going to create another one. Because I is still in use, I'm going to use J, and I'm going to say for J in range, let's just say 4, make it nice and simple and small. I'm going to print inner. And when I run this, what do I get? I get an error. Outer not defined. Hey, how about putting that string in quotations, you think? So let's look at the output. I have an outer loop. So 3 times I'm going to print outer. Events, and then after that, inside, I'm going to print inner 4 times. 0 through 3. 0, 1, 2, 3. Out to the outside loop, print outer. Do the inner loop again. 0, 1, 2, 3. Out to the outer, 0, 1, 2. And then I do it one more time. 0, 1, 2, 3. Now, this may just look like silly gymnastics right now and be semi-confusing, but later we're going to see that sometimes lists are set up in 2 dimensions so that you can keep numbers in a grid. So you will have rows and columns of data stored in a list, and a way to traverse or go across that row by column structure and look at every item is with this, with what are called nested loops. So the outer range would be the row, and then the inner range would be the column. So you would go row 1, 1, 2, 3, 4, 5, and you'd go across the row. And then when you got to the end of it, boom, you would drop down to the next row. So this is the way we will traverse squares of data later. So I wanted you to see that and understand it and not be too confused with it. Remember, this is a YouTube video, so you can play it and watch it as many times as you want, or you could stop it and get a screenshot of all of this stuff, so you can make your own notes and your own slides and your own stuff. All right, real quick, we got 2 more things to go through. Very quickly. What we've been doing thus far are basically called definite loops. I know I'm going to use range and do it 10 times. I know I'm going to do it 100 times. I know I'm going to examine every item in this list. There are situations, though, where we want to go into a loop and we want to repeat activity until a certain event occurs or a certain condition is true, or false, actually. So we want to have a construct that allows us to test a condition every time through a loop. And as long as that condition is true, we'll keep going through the loop. But once that condition becomes false, then we skip out of it and we move on to the rest of the program. And that is done with what we call a while loop. And you can see it turned orange. The keyword while is there. When we use while, we say while, and then we create a condition. What am I going to do? I'm going to kill 2 birds with 1 stone here. And I am going to say char equals, I want char to equal n. I said char equals n. So while char, actually no, I want char to equal y. And then I say while. Now I use a paren. You don't have to. Actually, I won't use it this time so I can show you what. While char not equal to n, jump into the loop. So this is going to be the silliest loop you've ever seen, because I'm just going to print loop. And then I'm going to say char equals input. Do you want to continue? And say yes or no. So give me a y or an n. And that's it. So what's going to happen? Character equals y. While character is not equal to n, that's true. I drop into the loop. Print loop. I say character, input, do you want to continue? I say y. So now character equals y. I come up here. While character not equal to n, still true. I print loop. I ask again, do you want to continue? I say yes. Same condition is true. I can go through this loop as many times as I want. But when I put n in, it goes up to the top. And it says while char not equal to n. This will now be false, because I've given it an n. And we will drop out of the loop, as you will see. All right, do I want to continue? Sure. And I can print loop out as many times as I want. You want to know a dirty secret? I didn't do any error checking. So anything I throw in there that's not an n is going to keep me in this loop. But if I put an n in, it's going to drop me out. As you can see, I get a, I should do something like this. Print the end. That way, do I want to continue? Yeah, sure. Okay, but when I put the n in there, I print the end and I drop out, because the minute I put the n in there, while character not equal to n becomes false. So the while condition is no longer true. I drop out of the loop and I go to the next line of code underneath the loop. That's an example. That's actually two different examples. The first and probably most important thing is that this is an example of an indefinite loop. You don't know when it's going to end, because it depends on the input from the user, which also makes this a second kind of loop, a loop called an interactive loop, where whether you end or don't end depends on the user and the user input. Now later, when the programming gets more sophisticated, it's not going to be just entering letters. It's going to be actions with your mouse. It's going to be, is your character in a certain place? You can test for that. While you can imagine a video game, while character in a center area fighting something, do this. And the minute you leave that area, boom, something happens. Like maybe your background changes, like mine just did, or other things like that. So this is an example of an indefinite loop. You don't know how many times you're going to go through it beforehand. You set up a condition and then change things interactively. So that is how we do while loops. There is one more thing I'm going to do, because I want you to see it, and I think it might be useful. Hint, hint, wink, wink, for one of the assignments. I'm going to create a list. Call it another list. And I'm going to, in this list, say 1, 2, 3, 56, 34, I can even say -5, it doesn't matter. 2, 5, 7, and give me one number, 100. Actually, I don't want it to be the end, because that kind of defeats the purpose, and you'll see why in a minute. Okay, I got a list with all those numbers. It doesn't really matter what they are. Let's say I wanted to add them up. So for I in another list, I want accummed equals 0, because I'm going to accumulate them. And I'm going to say accum equals accum plus I. Great. All right. and the sum is accum. Perfect. Assuming that's right. So I have my list, and real quickly down here I jump into a loop, just one command, and I run my accumulator and I find out what their sum is. Now, what if I were told that I want to grab the sum of those numbers up until I see 100? Wink, wink, nod, nod. How would I do that? That seems weird, and I don't know how to do that, because if I say I in another list, I'm going to go through the entire list, right? I can't just stop in the middle of a list. Well, it turns out that's not true. It turns out I can stop in the middle of a list and just jump out of it. The way I do it is this. For I in another list, I'm going to say if I is not equal to 100, accum, did I have that down there? No, I got rid of it. Accum equals accum plus I. Else, now what does else mean? Else means it's 100, because if I is not equal to 100, I add my list. Else, ready for this? Break. Turned orange, see? It's a keyword. What break does is throw you out of the loop. It's usually used for conditions like this, where you want to get to a certain value and then stop. This is called a sentinel loop. When you say keep going until you get to a certain value, then you drop out. It's very similar to what we did up here for the while. This waited for a character, and then when it got it, it dropped you out. So in a sense, this is a sentinel too. It waits for a certain value, and then when it sees that certain value, it gets out of dodge. So in this case, I set my accumulator to 0. I say for I in another list, so I'm going to iterate through this entire list, blah, 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 blah. And if it's not equal to 100, I'm going to add it to my accumulator. So I go merrily along, 1, then 2, then 3, then 56, then 34, then 67, all the way down the line until I read 100. For I in another list, if I not equal to 100, well, that's not true. So I do not add it to my accumulator, and I go to the else condition. And what does the else tell me to do? It says break. And what happens when you have a break inside of a loop? You break out of that loop. Now, you only break out of the outer loop. You don't break out of the outer loop. You only break out of the loop you're in. If this were a nested loop setup, you wouldn't break out of the entire structure. You would only break out of the loop you happen to be in. So if we run this, let's make our lives a little easy, and realize that 1, 2, 3 is 6, 8, 13, 20. Should be 20. Let's see what we get. Hey, the sum is 20. So what happened is we went into the loop. We checked to see if we see 100. If we don't, we add it to the accumulator. But then once we saw that 100, this was no longer true. We triggered the else and we said break. Get out of here. Go ahead and break. And then once we broke, we came out of the loop and we printed the sum is accum. So that's an example of a sentinel loop. Okay? I am quite certain this video went crazy long, which is good though, because loops are a very important thing. And eventually I want to get you to the point where you're just secondhand using loops to solve simple problems. I want to do this, I want to do that. And tomorrow night, tonight, I have to clean up, do some things, and then get some sleep because I have to be up at 9 o'clock tomorrow, because the tailgate will start at 9:30 in the blue lot, and then we will be going in to see Rutgers play Kansas at around 11:30. And I don't know, I do not know what to expect, nor do I care at this point. But after the football game, I'm going to come home here, rest up a little bit, and then I'm going to do another video. The video I'm going to do is solving Project Euler problem number 6. And that's where you're going to see I'm going to use loops, and I'm going to say, okay, I want to do this, I want to do that, and we're going to solve one of those problems. And you're going to see how we use loops and sequences and these constructs to start solving problems. So go watch this video again. Go reread the slides. Use all of the resources I'm giving you. If you still think you're a little hazy on loops, go to the resource section in Sakai and look up one of those free books, How to Think Like a Computer Scientist, Think Python or whatever, and read a little bit on the chapter of loops. Maybe you just need to have that one example or have it explained to you in that one way where you get that aha, you get that eureka moment. You're going to be like, now I get it. Now I understand what loops are for. They're not just to print numbers. They're to do the same operations to every single item of a sequence. And while that sounds corny in general, when you see it in action, when you see us creating lists of squares, or when we're going through a list and adding them all up until we get to a certain number, you can see how they might get useful down the line. And you'll see they are very useful down the line. Again, right now, because we're just starting out, we're only doing things with simple data types, floating points and integers. I'm using integers exclusively here. We could also use strings, but later when your data gets more complicated, and complicated is a bad word, complex, you're going to understand it. It's going to be easy. But when it's more complex, you're going to see that as you can loop through different structures and loop through different objects, and it's going to be extremely useful. And don't worry, you're going to get it. We're going to be doing more with loops in Unit 3 because in Unit 3 we're going to be dealing with file input and output. And I'm going to show you how to use a loop to go through an entire file. And at that point, we're going to learn about the speed of computers and how you can have very, very large files and, blast right through them, add them together, do what you have to do, and do all kinds of things, okay? All right. Whew. That was a good one. We are meeting on Wednesday. I'm probably going to remind you again tomorrow when I solve the Euler problem. You now have both assignments for Unit 2. Think about them. Think about what we talked about tonight when you're thinking about those problems. Eric and I spent a good part of today grading, like I said in the announcement I released before. And tomorrow I'm going to send out all the emails with everybody's points for the unit. Everybody did really well. There's no worries out there. No worries whatsoever so far. Spend some time on that middle of the semester project where you have to go spend time with Learn Python the Hard Way and Code Academy and things like that. Because Unit 3 is going to be some new interesting concepts. We're going to be talking about functions. We're going to be talking about file I/O. And we're also going to be talking about something that's going to, well, I remember I told you loops open up your world and let you start solving some real problems. But we're going to start looking at libraries and other third-party libraries and ways to import libraries of already existing functions so that you can start using them on your data. And that is really going to open up the world to you. Okay? So spend a little bit of time on that project because when you get to Unit 3, A, you're going to have things to do for Unit 3, but B, you're probably going to get gunned up and want to start solving your own problems, and we're going to be getting more into data science at that point, and you're going to be like, oh, I can't believe I have to spend 2 hours with Code Academy. So do it now. Plus, there's always some method behind the madness. It's extra practice. It's a way for me to get you a ton of extra practice doing these simple things, because while they seem simple, maybe a little boring, they're the foundations, and you're going to need to burn these things in your brain so that you're not even thinking twice and you're on interactive Python and you're blasting through solving problems. And you're going to get there. Trust me. I know for a fact you're going to get there. All right? So that's it for me tonight. I'll be back tomorrow. I don't know what Rutgers is going to do. The Mets won and the Nats lost. So the Mets magic number is 1. All hail Mookie Wilson. You guys have a good night, and I will definitely be in touch with you tomorrow, okay? I'll talk to you later. Bye-bye.